find the in-center of the triangle with vertices 1, root 3, 0, 0 and 2, 0. So therefore, it's interesting to see that one of the vertices of this triangle is the origin 0, 0. The other vertex is lying on the point on the x-axis 2, 0, and only the third vertex 1, root 3 lies completely between the quadrants or between the axes. Let's check the lengths of sides. AB given by distance formula will be 1 minus 0 the whole square plus root 3 minus 0 the whole square. So that will be square root of 1 plus 3. So therefore that will be equal to square root of 4, which is equal to 2. BC be given by 0 minus 2 the whole square plus 0 minus 0 the whole square, and that's given by 2. AC is given by square root of 1 minus 2 the whole square plus root 3 minus 0 the whole square. So that's square root of minus 1 the whole square plus root 3 the whole square. So that is also 2. We observe that the length of the sides of this triangle are equal to each other, which means that it's an equilateral triangle. If it is an equilateral triangle, the in-center of this triangle will correspond to or coincide with the circumcenter as well as the orthocenter as well as the centroid of this triangle. So instead of using the formula for in-center, which is possible by the way, it is possible to apply the formula for calculating in-center of this triangle. However, the easiest formula to use is the formula for calculating the centroid of the triangle. So therefore, the coordinates of in-center will be equal to the coordinates of the centroid of this triangle, and that's given by 1 plus 0 plus 2 divided by 3 root 3 plus 0 plus 0 divided by 3. And that is 3 divided by 3, so that's 1, and root 3 divided by 3, that's 1 over root 3. Thus, we get option D as the correct answer to this question. The in-center of this triangle is 1, 1 over root 3. Second and harder question. If the circumcenter of the triangle formed by the points 0, 0, 2, negative 1 and negative 1, 3 is at 5 by 2, 5 by 2, then find the coordinates of its orthocenter. So therefore, in this question, we have been given only the circumcenter, and we are supposed to find the coordinates of the orthocenter. But then, in order to use that theorem, where the circumcenter, centroid and orthocenter divide each other in a certain ratio, we need the coordinates of at least 2 points in order to use the section formula. So therefore, what is that theorem? Suppose this is the orthocenter, centroid and circumcenter. They divide each other in the ratio 2:1. We know the circumcenter, and that's been given as 5 by 2, 5 by 2. We don't know H, we don't know G. But then what else have we been given? We have been given the coordinates of the vertices of the triangle. From that, we can calculate G as sum of x coordinates divided by 3, sum of y coordinates divided by 3. So that's 1 by 3, comma 2 by 3. And thus we know 2 of the 3 points involved in the section formula. Suppose we let h be the point x1, y1. Then the x coordinate of the centroid equals 2 into 5 by 2 plus 1 into x1 divided by 2 plus 1. 2 plus 1 is 3, so the 3 from both sides gets cancelled, and we are left with 5 plus x1 is equal to 1, thus giving x1 is equal to minus 4. Similarly, we can obtain y1 as 2 into 5 by 2 plus 1 into y1 divided by 2 plus 1. So that's 3, and you get y1 as 2 minus 5, so that's minus 3. And so we get x1 as minus 4 and y1 as minus 3. And so that gives us option A as the correct answer. That is the coordinate of the orthocenter of this triangle.